afternoon again to everybody, and welcome to today's webinar entitled Let It Flow, Culvert Design 101, covering basic hydraulics, culvert location, and end treatments. Our two presenters today are Patrick Biro and Roger Goobie, members of Armtec-Drainage Solutions Business Unit, both of whom I'll introduce more shortly. My name is Janine Yetke, Director of Marketing for Armtec-Drainage Solutions Business Unit, and my group runs the webinar program, and I'll be your host for today's event. We also have James Carter on the line, who is our technical moderator, and who will be running questions and answers at the end of the session. Before we continue, I'll quickly go over some housekeeping items. During the presentation, if you have any questions, please enter your question into the question log. We will have a question and answer session after the presentation is over. If you're sitting in a boardroom or with a group of people, please designate someone to collect and input the questions from the group into the question log. We do encourage everyone to join in the discussion today. So if we're not able to get to your question at the end of the session, please rest assured we will respond through email. So please feel free to enter questions at any time during the presentation. As a reminder, attending the session will qualify you for a 1-hour technical informal CPD credit. For those who have registered directly, we will send out the certificate to the email provided upon login. For those who are attending as a group, please compile your list of attendees and send the attendance list with the required details to webinars@armtec.com. I'd like to start off with a brief introduction to Armtec. We are one of Canada's oldest and largest infrastructure companies, supplying solutions ranging from steel and HDPE-based bridge and culvert materials to precast building systems. With locations across the country, we are well positioned to serve your needs wherever you are. We also have an international sales group to support you with project locations around the world. As you can see, Armtec offers products in a wide range of categories, including precast products such as building systems, parking structures, and sound wall systems. On the drainage side of the business, we offer engineered steel bridge solutions, soil retention systems, highway safety products, and of course, related to today's presentation, pipe and culverts, stormwater management systems, and much more. We serve numerous sectors from municipal to forestry and mining and energy. More about how we service these sectors can be viewed on our newly revamped website or through discussion with one of our experienced sales representatives. With our centralized engineering department and regional engineers, Armtec has the exceptional capability to fully support design and challenging engineered project requirements. Our company also has the expertise to take your project through all phases of the design and construction process with the design, build, delivery method. Today we're going to be presenting best practices in culvert design. For any project that you undertake, proper design and installation are critical success factors. And nowadays, with greater runoff levels from bigger storms and weather events, and with water characteristics changing due to urbanization and water pollutants, we can't take for granted that just replacing existing culverts with the same solution will meet the future needs of the affected areas. And therefore, there is a need to critically evaluate flow capacity, proper culvert placement, culvert materials, and end treatments to ensure that the right solutions are in place. Our webinar, titled Let It Flow, and Good Hydraulic Design does just that, has generated a lot of interest. And we hope that this will help build your understanding of the design methodology involved in these projects, and we believe it will help set the stage for your next culvert project or upgrade initiative. Presenting today are two Armtec employees, Patrick Biro and Roger Goobie. Both Patrick and Roger have a wide range of experience with solutions to deal with water management, which they will present today. Patrick is Armtec's regional engineer based in British Columbia. He has 14 years of design experience with buried steel structures and has been actively involved in the specification, design, and construction of numerous projects from small stream culvert crossings to long-span structural plate overpasses on mine haul roads. Roger is Armtec's sales representative located in Newfoundland. He has 25 years of experience in the manufacturing and sales of infrastructure products. He consults regularly with municipalities, contractors, and consultants to identify the best solutions for their needs. He has been involved in the installation of products from small forestry crossings to large structural plate overpasses on the Trans-Canada Highway and supports Armtec's entire portfolio of drainage products. Both of them look forward to plenty of questions and answers after this presentation, so make sure you keep them coming. And with that, I will hand off this presentation to Patrick. Welcome, Patrick.
Okay, well, welcome to the show, everyone. Today we're going to take you through some culvert design basics. I'll start us off with talking about how to size culverts, some best practices, and choosing the right materials. Then Roger will take over and talk about different types of culverts and end treatments. By the end, you should have a good idea of how to select and design the right culvert for your site. So to start off, we're going to go through some hydraulics of culverts. Be warned, there will be some equations on these slides. But don't worry, they're mostly there just to make it appear like I know what I'm talking about. We're really just going to be focusing on the general concepts. Let's start off with the basic concept of flow through pipes and culverts. When we talk about culvert capacity, we're usually talking about flow rate or discharge rate. Visually, you can picture it as water flowing out of a pipe or a hose. In terms of measuring flow rate, we look at this as water flowing through a cross-sectional area at a certain velocity. So if you know the size of your pipe and how fast the water is traveling through it, you can figure out the flow rate. Since I know everyone loves math and measurement units, let's go through it. With the size of your pipe, you've got your cross-sectional area A in square meters. The water is traveling at a velocity V in meters per second. Simply multiply A times B to get the flow rate Q in meters cubed per second. Now, let's introduce you to some of the factors that can influence velocity or flow rate through a culvert by talking about open channel flow. When we talk about open channel flow, we're usually talking about the almighty Manning's equation. This equation describes the relationship between the velocity of water and slope and friction force, with slope and friction forces. So the steeper the channel, the faster the flow. That's just gravity helping out. There's also friction between the water and the inside of the channel or pipe. So the relative amount of water in contact with that pipe surface and the pipe roughness will act to slow the water down. It's that Manning's end term in that equation that is the measure of pipe roughness. So let's take a look at this chart comparing different culvert types and their corresponding Manning's end number. The first few culvert types there on the chart, they're all corrugated pipes, going from larger to smaller corrugations. You can see how the numbers decrease as the pipes get smoother, right? So the smoother the pipe, the smaller the Manning's end. You should also note that some of the corrugated pipes have a roughness that varies with diameter. Not a CSP acts in this way. So the maximum numbers here are shown. Now Roger is going to go through most of the culvert types and corrugations, so you'll get to see them in all kinds of pretty pictures later on. Let's talk about the concept of conveyance. Conveyance really is just a simple term that can be used to describe pipe capacity. By rearranging some terms from that Manning's equation and taking slope out of the mix, you can get this term K that you can use to compare the capacity of different pipes based on their size, shape, and roughness. Roughness is obvious. We can easily see that the larger that Manning's end number is, the smaller the conveyance. Right? The rougher the pipe, the less conveyance. But let's look at how shape can influence the capacity of a culvert. Here's an example of two culverts, a round pipe and an arched pipe, made from the same amount of pipe material. This is actually exactly how we make these arched pipes. Right? We take a round pipe, we get all the workers in the plant to sit on it, and then squish it down to make this shape. Now, arched pipe is slightly less end area than the round pipe, just due to the nature of the shape. But let's say that the water elevation is the same in both pipes. Because of the squished down shape of the arched pipe, we have a wider waterway area. This cross-sectional area here is bigger. It's a bit bigger when flowing partially full. And we know the larger the area, the larger the flow rate. But it's not just the area that influences conveyance, right? It's also the ratio of the amount of water to the surface area in contact with the pipe. So what we end up with is a pipe shape that can be much more efficient than a round one, flowing partially full. And this is the shape that is cherished by hydraulic engineers everywhere. Okay, so enough of the really basic concepts. Let's talk about actual culvert design. When we're talking about culvert design, we're usually talking about getting the required discharge to meet the desired headwater elevation, okay? So that headwater elevation, that's just the elevation at the inlet of a culvert. Sometimes it's desirable to prevent the headwater from submerging the culvert. It's always desirable to prevent the headwater from overtopping the road. And so this is a key factor in design of culverts. Now, there are two main types of culvert design to consider, and each type depends on what controls the amount of water that can flow through the culvert. The first type is an inlet control culvert. This is where the capacity of the culvert is governed by the amount of water that can enter the culvert. Water can flow through and out of the culvert faster than it can get in. These culverts, you'll usually find them as the ones that are on steeper slopes, and the flow through the culvert is rather shallow, almost always partially full. So discharge or capacity is affected by the size, the inlet geometry, and the headwater elevation. It's not influenced by the roughness of the pipe. So don't let anyone tell you that you need a smoother pipe or an inlet control culvert. It won't help you. If you need to increase capacity, you need to either increase the size or change the inlet geometry. So what do I mean when I say inlet geometry? It's the end treatment of a culvert, and it influences how easily water can enter. In a case of no end treatment at all, where a contractor has just buried a square-ended pipe, letting the ends just stick out of the embankment, that's called a projecting end. The projecting end makes it the toughest for water to enter an inlet-controlled culvert, and an outlet-controlled one too, but we'll talk about that in a bit. Now, if you just cut that projecting end on a bevel or on a miter, you increase the inlet capacity, right? So you can actually increase the capacity of an inlet-controlled culvert just by cutting the end of it on an angle. It's like magic. Well, maybe a little bit of science. What you're doing is you're reducing the amount of energy required for the water to enter the culvert. You can also increase inlet capacity by, say, adding a head wall, and even further by somehow funneling the water into the culvert. Okay, so we talked about inlet control. Now we're going to talk about, obviously, outlet control. With an outlet-controlled culvert, the capacity is now influenced by energy loss. This is because water can enter the culvert faster than it can flow all the way through. These culverts are usually flowing with low velocity over flatter slopes. It gets a little more complicated with outlet control culverts, but at least you'd be glad to know that I didn't waste your time talking about pipe roughness and conveyance, because they come into play here. Friction and slope are now factors that influence the capacity of an outlet-controlled culvert. In outlet control, the relationship between the headwater and the tailwater elevation is basically head loss from the entrance of the culvert to the exit. There's entrance loss, there's friction loss, there's exit loss to consider. All right, now I'm going to save you the pain of showing you any more equations. I'm not even going to subject you to any of the fun nomographs out there. Those are tools for consultants working in hydraulic design. There's also software out there like Culvert Master that can make things really a lot easier for you. I just want everybody to kind of understand the difference between inlet control and outlet control culverts. Now, lastly, I just wanted to talk about some other hydraulic considerations. Really important to be conscious of end treatments and how they can harm or protect a culvert. Uplift forces can cause serious up-end failures of an inlet if it's been allowed to scour. This can be avoided by anchoring the inlet, but it is always best to protect from scouring. If water is able to force its way into the embankment alongside the culvert, fine material and eventually all material can be washed out. And of course, that's a bad thing, can lead to failure. End wall protection and anti-seepage colors, those are the kinds of features that can help prevent piping. So essentially, culverts can fail if not designed with adequate hydraulic capacity, but lack of end treatment can still lead to failure on a properly sized culvert. You can see some examples here of piping there on the left, embankment failure, and the ultimate culvert floating downstream. Nobody wants that, right? So, I've mentioned the importance of end treatment here, and later on, Roger is going to show you all kinds of end treatments that can be used on culverts. So keep that in mind. All right. Also important in culvert design is placement and alignment. Some of the topics we're going to discuss are requirements for a structurally viable culvert, and some could just be considered best practices. So to start off, I just want to describe the buried culvert system that we're going to be talking about. This system is composed of a buried culvert of a certain diameter under a certain amount of soil under some kind of traffic load. So I'm going to be talking about a couple items that need to be considered to make a flexible culvert successful in this system. Every flexible culvert has a minimum amount of soil cover required. The minimum amount will depend on culvert type and particularly size. Most flexible culverts are designed in compression, which is why it makes them so darned efficient. Right? There's a minimum amount of soil cover required to be able to safely neglect bending in that culvert wall. Now, if flexible pipes were good in bending, then they wouldn't actually be flexible. So you definitely need that minimum amount of cover to minimize that bending in the wall, in the culvert wall. You also need a minimum amount of cover to prevent what we would call a soil wedge failure between the culvert and the road surface. Now, I can't tell you how many times I've been asked in my 14 years of designing culverts and culvert type structures, can we go lower than minimum cover? The answer is always no. That's why we call it a minimum. Now, you not only have to worry about the space between a culvert and top of the road, but if you have multiple culverts, you need a minimum distance between them as well. There's pressure all around the culvert, and if two culverts are too close together, that pressure overlaps. You get additional load on your culvert wall. So we have a minimum spacing. The minimum spacing is dependent on the shape and size of the culvert, as well as the type of backfill between them. It is possible to use a flowable fill or CLSM to get culverts closer together, but whether you use that type of fill or traditional compacted backfill, you'll always need to consider how much space the contractor will need to place the material and compact if necessary. Next, we're going to be talking about alignment. Good culvert alignment follows the waterway. It's tempting to install a culvert perpendicular to the road because installation is simpler and the pipe lengths are minimized. But changes in alignment of a stream can change the landscape both upstream and downstream. Right? That's something we want to avoid. The culvert should have a direct entrance and exit, or erosion of the embankment at the inlet or outlet is just a matter of time. If possible, avoid a course change near the exit, or try to smooth out the transition as much as possible. Now, also note that most culverts can be fabricated with elbows, allowing you to put a bend in a pipe and follow the natural bends in the stream. And this eases the hydraulics of the stream. All right. Now, in terms of vertical alignment, there's also a lot to consider. With new embankments, it's a sure bet that there's going to be some settlement. To avoid the eventual dip in the culvert, the pipe can be installed on a camber so that it eventually settles out flat over time. You also need to anticipate sediment. When you install a culvert below stream grade, you can expect sediment to accumulate up to at least the natural stream depth. So you need to size the culvert to account for that area loss. And you also need to account for different roughness at the bottom, if that affects the culvert hydraulically. You also need to place the culvert on the correct grade. If you have a culvert that is too steep compared to the natural stream grade, you're going to accumulate sediment at the outlet and eventually create a perched outlet by way of erosion. Now, it's not just the pipe grade that we need to worry about. Alignment of the embankment grade is also very important when dealing with flexible culverts. To get a good culvert alignment with the natural watercourse, it's often placed on the skew to the road, like in the diagram there on the left. We need to be careful here, because there is also a natural tendency to grade the embankment slope perpendicular to the road. When you do that, by the time you get to the end of the culvert, you get what we see here in section 8A, an imbalance of fill. And I can't mention this enough, flexible culverts are flexible. If you have an imbalance of fill, there will be a tendency for that culvert to roll. Most certainly, there will be deflection. In the worst case, failure. So to avoid this, you must adjust the grading to give balance so that at all points along the culvert, soil elevation is the same on both sides. You can achieve this by either warping the embankment, as shown in the diagram, or by using full height head walls. Now, lastly here, I just wanted to mention fish-bearing streams. Every jurisdiction is a little bit different, but there will always be local guidelines on how to accommodate fish-bearing streams. Often, a natural stream bed is required to help with spawning and fish passage. Some regulations will allow for embedded culverts, and there really is a lot of success with these types of culverts in many areas. Now, sometimes the tendency is to use an open bottom arch because it really is an easy way to create or use a natural stream bed. And it's definitely a bit easier than moving bedding material into a closed bottom culvert. Now, however, an open bottom structure is only absolutely required when dealing with a sensitive stream where the natural bed must remain undisturbed. Okay, so that's it for sizing and alignment. Now let's talk about durability. More specifically, we'll be talking about coatings and materials and how site conditions can affect service life of your culvert.
We just had a couple questions come in from the previous section that I thought we might get to here. There was a clarification on Manning's N, and someone had mentioned they hadn't seen it applied to deep corrugated. Has it been verified, and is that basically they were just asking how it was verified?
That's a good question. It really is for deep corrugated. It's an estimated Manning's N. It very often doesn't come into play because most deep corrugated plate are open bottom structures.
Culvert slopes compared to ditch slope. Doesn't increased culvert slope allow for cleaning of the culvert?
Well, yes. Well, if you increase culvert slope and you have sediment in the natural watercourse, then you could still end up with sediment at the outlet end. I think that's what the person was asking about. But yeah, you could increase velocity by increasing the slope, but it's often not recommended because of what happens at the outlet end.
That's great. Thanks, Patrick.
Okay, so we're switching gears to durability. So right off the bat, let's look at these coatings, or the coatings available for steel culverts. You know, we've got the old standby galvanized steel, we've got aluminized type 2 steel, and we've got polymer laminated or polymer coated steel. So why all the different coatings? Well, because bare steel interacts with air and moisture to cause a little something we call corrosion. So we put a coating on it to delay or prevent this corrosion. Now, the different coatings are used depending on soil and water chemistry and also abrasion. When we talk about soil chemistry, we're usually talking about pH and resistivity. pH, most people are familiar with this term. It's a measure of how acidic or alkaline the soil or water is. Resistivity, that's actually the inverse of conductivity. So corrosion is an electrochemical reaction. So intuitively, less conductivity results in less corrosion. Conductivity is based on the balance between mineral and salt concentrations. It's all about the ions in the water. Now, testing for pH, hardness, and chlorides, it's actually very easy. You can either do it yourself with simple test kits, like the ones you would use to test your pool, or you can send samples to a lab for a pretty modest cost. You do want to remember that you'll want to test multiple times over the course of the year, because water chemistry can change from season to season. All right, so I'm showing a few charts here, a lot of fancy bars here. What we're actually looking at are recommended ranges of pH, resistivity, hardness, and chloride concentrations for the three coatings that we just looked at. If we look at the top one, if we look at pH, we can see the galvanized pipe doesn't do well in water with a pH less than 6. That's about the pH of saliva or milk. It's almost neutral. Now, aluminized pipe does a bit better in more acidic fluids. You can run coffee through a culvert, but orange juice, that's a no-go. But in all seriousness, the pH of 5 is right about where we would call acid rain. Pretty important to consider in those at-risk areas. Now, remember that 1 pH doesn't sound like much, but 1 pH lower actually means 10 times more acidic. So aluminized steel can actually handle 10 times the acidity that galvanized steel can. Resistivity is also important. That's a function of hardness and chloride concentration. Galvanized steel requires at least 2,000 ohm centimeters of resistivity, and aluminized a little bit less so, for the water or soil to be considered non-aggressive. Hardness, that's beneficial for any coating, and it's also why galvanized steel does so well in hard water areas and is perfectly appropriate for those types of areas. That line scale that builds up in your coffee makers and dishwashers, that's a protective coating that actually helps to neutralize acids in water. It's like antacid for your culvert. You can see on all the charts that polymer laminated culverts, they cover the whole wide range in all those charts. Now that's because polymer is fully inert, and the coating, it acts really as a true barrier coating. Okay, so let's compare the three coatings. We've got galvanized steel, which has a zinc coating, great in hard water, like we just talked about. It will last maybe 50 years in non-aggressive conditions. The key here is non-aggressive. When determining service life, actual water, soil, and chemistry needs to be known. Excuse me. You need to do the testing and calculate the actual service life. When I talk about service life in these slides here, I'm assuming non-aggressive conditions. Aluminized steel has a pure aluminum coating. This coating is the same thickness as the zinc on galvanized steel, and it's a little bit lighter because aluminum weighs less than zinc. This coating can do well in soft water and mildly acidic water, like acid rain and coffee that we talked about earlier. You can expect an aluminized culvert to last about 75 years in non-aggressive conditions. And this really is because aluminum oxide patina that develops on the surface, that's a great barrier against acids and prevents corrosion. Now, polymer-coated steel has a much wider range of appropriate site conditions. Again, it's because that polymer acts as an inert barrier coating. Now, it is very important to remember that coated steel is exactly that. It's coated steel. So if you lose the coating, you lose the protection. So you will need to consider abrasion, the sediment, sand, rocks, etc. that are scraping against the culvert walls. We talked about coatings on steel pipes. Now it's time to talk a bit about plastic pipe. Polyethylene pipe is in common use for drainage worldwide, and steel reinforced polyethylene pipe options are still growing. There's definitely an industry trend towards plastic pipe, and the trend is largely because of durability. Polyethylene, it really is a great pipe material. It is nearly completely inert and has very high abrasion resistance. and actually better than all the common pipe materials available. And there is absolutely no risk of corrosion. It's so inert that if you looked at all the chemical resistance data, it would be tough to find chemicals that can harm polyethylene. Jet fuel can't, so no jet fuel. Okay, lastly, there is always that ultimate question, how much does it cost? Choosing a coating or material is definitely a benefit-cost decision. Generally, increased durability is going to cost you more. You'll need to ask yourselves questions like, is the cost of this polymer pipe going to be worth the price? When aluminized steel will still last a very long time. There are tools out there to measure site chemistry and determine exactly what type of coating or material that you need to meet the owner's service life requirements. What you see here are just some relative costs of pipes and coatings using galvanized CSP as a baseline. Now, keep in mind, these are just averages. They're not exactly the same across all diameters and won't take freight into account. Some of the pipes will also carry a premium because they may be watertight, and others maybe carry a premium because they are available in larger sizes. What you can take away from this are things like, for a bit more, aluminized pipe will give you more service life, whereas polymer laminated will last even longer, and that's awesome, but might not be in the budget. I do want to strongly suggest to all the specifiers out there that when specifying culverts, specify the coating on the tender. Specifying service life is not always enough, as your low bidder will be looking for the cheapest pipe that might meet your requirements. So if you want to make sure the pipe meets your requirements, specify the coating. Okay, so I'm just about done talking here. To sum everything up, here's just a list of all things that contribute to good culvert design. We've talked about all these things. We've talked about sizing pipes hydraulically, protecting inlets and outlets, maintaining good alignment both laterally and vertically. We talked a bit about backfill requirements, and of course, selecting the right materials and coatings for that desired or required service life. Finally, I did want to mention two great sources of information for the design of culverts, the Corrugated Steel Pipe Institute and the National Corrugated Steel Pipe Association. At their websites, you'll find all kinds of technical information, all kinds of references that I use on a daily basis, including these texts that are used in culverts and hydraulic design. We are now going to travel 7,000 kilometers east, where Roger is going to show you the different types of culverts, coatings, and end treatments that fit into everything that we've talked about so far.
It's James here. We're relatively on schedule, and there's some questions that came in from your section, so I thought we might take a few of those now before we hand over. There was a question about the 600 mil CSP and what lengths it comes in. Okay, I think Roger might talk a little bit about culverts, but okay. Lengths for steel culverts, generally 6 meters or 20 feet, but custom lengths are available. And then what is the maximum diameter of plastic pipe available? Depends on what type of pipe. Our particular corrugated polyethylene goes up to a 900 millimeter diameter. There are other types of plastic pipes, including steel reinforced, that can go up to 3,000 millimeter diameter, or 10 feet. Okay. And stealing Roger's thunder here a little. I'm sure he's going to talk about these. I'm kind of cautious about that too. There were some questions about relative pricing, and we don't want to steal Roger's thunder because I think he has a really good slide on showing relative pricing of HDPE versus steel, so we'll leave that one for him as well. And there's a few others that have come in here, and we'll take those at the end as well. So, Roger, over to you.
Welcome, everyone, and thank you, Patrick. Thanks for everyone taking time in today. I'm going to talk to you about different types of culvert types and applications. First, we get into our basic corrugated steel pipe, 100 millimeter to 3,600 millimeter. Comes in various corrugation types, 5 different corrugations. You get your 38 by 6.5, 68 by 13, your 76 by 25, 125 by 25, and then your ultraflow. Your ultraflow is a square rib culvert, external rib on the culvert, 19 millimeters by 19 millimeters. And when it's in the field, it acts as a smooth flowing pipe with a Manning's end of 0.013. There's a variety of different coatings, as Patrick alluded to earlier. You galvanize, aluminize type 2, and you polymer laminate it. But we also, in some locations, we make it in a pure aluminum culvert material. It's not a coating, it's a solid aluminum pipe and used mainly in the coastal areas. So main applications for the culverts, forestry roads, highways, and storm sewers. Then we move over to our Boss 2000 HDPE pipe. You get in 210 or 320 kPa, and the question was you get to 100 to 900 millimeter. But there's also available, you have 1050 to 1500 in the HDPE, but the only factor there is the stiffness, and the stiffness would range then from 95 to 179, so a little lower stiffness. Dual walls, corrugated outside, smooth inside, and a Manning's end of 0.012. And a pH range 1.25 to 14. They come in different types. You have a plain end, which is used with a split coupler or a clip bell. Both those types are soil type joining systems, or they can come in the bell and gasket, which is a water type system. And applications, storm sewers, drainage, and forestry roads. We move over to our soil steel structures. Multi-plate corrugation. It's 152 by 51 corrugation. Come in 3 millimeter to 7 millimeter thickness, and a variety of shapes and sizes. Round, vertical lips, underpasses, just to name a few. And they can be custom size. Galvanized or polymer coated. In this particular picture you see here, it was on a highway in Heart's Content Barrens in Newfoundland. And as you can see, there was two different coatings used in this particular project. The invert and your corner plates were polymer coated, and your cover plates were just plain galvanized. As we see most of your corrugation and abrasion is in the invert your pipe. So usually the first place to go. So the polymer coated plates were put in the bottom for the extra protection. These are shipped to site in modular lengths, 610 millimeter increments, and they're stackable and nestable plates, so that they're very economical to ship. And like I say, culverts, underpasses, bridges, a variety of different applications for them. Then we move over to our heaviest soil steel structure design, which is called our bridge plate. Corrugation, 400 millimeter by 150 millimeter corrugation. Come in standard thickness of 4.3 to 8 millimeter, and standard spans 4 to 18 meters. And again, variety of different shapes and sizes, and also custom applications. If you've got a project out there that you've got a particular size in mind, particular shape, our engineering team are very capable of designing to your needs. Modular lengths, 1200 millimeters, and again, galvanized or polymer coated. Then we move into our, a lot of our coastal areas, because of the seawater, very corrosive, salt, get into our aluminum structural plate, 229 by 64 corrugation. It's a marine grade aluminum. Corrugation abrasive resistance, and the salt water. This one was in Lawrencetown, Nova Scotia. And as you can see in this particular picture, the invert of the box culvert, it's aluminum as well, thus not needing any concrete footings. The invert would act as your concrete, act as your footing design. And again, to sum up in our structural plate, as you can see the picture, it's a structure that's being shipped to the site, very economical, shipped to remote location, very ease of installation without large cranes, You can readily available the machinery that's on site and assemble with unskilled labor. Less design and construction time required, allowing earlier project completion. And some of the benefits, deep bury applications, heavy live loads. They typically, when they're designed, have a reserve capacity and the seismic forces. Also benefits, bridge decks, eliminates them, and the icy deck problems during the winter months. No deck deterioration problems, the maintenance, less there. And also if you want to widen out your roadway, just matter of you can extend to our structures either side, and the roadway is very simply widened out. And your slopes and that, you can put a backfill to the environmentally preferred natural appearance. Now we'll move on to in-treatments. I got a variety of different, some site pictures that have been taken from across Canada. So we start off with the basic CSP. These two particular pictures, one is just with a small cobble, the other one is a little bit larger armor stone. As Patrick alluded to earlier in his presentation, these are just project ends, just square in, so would cut down some of your flow properties. And these are used mainly in your highway and forestry crossings or in driveway applications. This one here, as Patrick had in one of these slides, he talked about an arch culvert, flow properties. This is a aluminized arch pipe, large diameter, and armor stone projected protection. This particular area was, everyone have heard about the Hurricane Hel-Cor that hit Newfoundland back in 2010. This was a location that was in the Trans-Canada Trailway, and when it let go there, it took out the Trans-Canada as well. So this was what was put back there. It had increased the higher flow rate with the arch pipe, and also you can see that there was a couple overflow pipes put in there as well. Then you can also get into creative in-treatments. This particular picture was wooden plank that was used to create a head wall. And these custom treatments are usually used in areas like parks and historic sites where you want something to be aesthetically appealing, to look at and blend in with the surroundings. So I'd say there's a lot of different applications out there that you can use. Back to our HDPE pipe. This is a picture just in a forestry road, projected ends, just a natural backfill off the roadway, and the ends extended out. The pipe ends up being a little bit longer usage there to compensate for the road slope. If you want to decrease your length of your pipe, you can use a cast-in-place concrete head wall system. Allows the culvert to be shortened, and it protects the roadway from erosion and pipe undermining. And this is used in a municipal application, and you can also put your safety handrails if you're in a residential area somewhere you don't want kids and that falling over in the ends of the pipe. Want to go a little bit more elaborate? Pro-Ecolite composite head walls. These help funnel the water into the culvert, and as Patrick talked about, increasing your flow. If you funnel it into it, it increases the flow of your pipe. Aesthetically appealing, and these here can be equipped with trash racks or safety grates. Also, you can talk about with bevels. This particular project was a tunnel liner used as a reline. It was in a national park in Newfoundland. It relined the existing multi-plate, beveled the ends, put concrete wing walls to add for scour protection in the event of high water and flood conditions. You get into your armor stone. This is aluminum multi-plate. Underneath, as you can see in the picture, there's a concrete star wall that the structural plate was anchored to. A large armor stone put around it. Gives you minimum roadway protection during storm conditions, so the soil still can, high water conditions can still erode away, but in normal conditions, the armor stone gives you good protection. Want to step it up a bit. Welded wire walls. These wire walls can be in the field, shaped to whatever shape your structure is. The front face of the wire baskets are filled with rock, cobble, or flat slate, and very easy to install. As you're backfilling the structure, the erection of the wire walls basically goes hand in hand. As your structure is being backfilled, you're installing your walls as you go. This one here, particular one's a multi-plate on concrete footings. Then you go a step further, concrete head walls. This particular picture was in Sydney Mines, Nova Scotia. It's a trench coat CSP, concrete head wall, a safety rail, and an armor stone placed out around it. So good protection in floodwater. Then increase a little bit more, you get concrete head walls and gabion basket wing walls. This one here was aluminum box culvert, and good retaining for lower fill heights, and again, aesthetically appealing when you're into a community. Then you have the welded wire wall in conjunction with the concrete head wall. This one here adds great scar protection. This particular picture, when this job was finished, was a safety rail put along the top of it as well. So as you can see in the picture, the rock face gives it a nice appearance. This particular project as well, as you can see, this one was in the earlier in my slides. This was the one that was with the polymer coated in the inverts and galvanized in the cover plates of the multi-plate. If you're in an area that you want to give it a little bit more of a green appearance, this particular one was in Suncor, Fort McMurray, Alberta. It's a green mirror mesh in the wire wall. It's a geotextile that give it a green appearance, and in an area that, like say, aesthetically appealing, gives you a great benefit. We move on. This one's a bridge plate, complete with a bridge plate head wall and a bin wall wing walls, used in higher fill areas. This one here is at a tank farm at LNG Canada in St. John, New Brunswick. The access roads were elevated in the case of spills, and with the higher heights, the bin wall was a great fit there. Then we get into our geotextile end treatments, fabric wrap walls, or your geocell walls. And both these types using the natural fill and a geotextile or the geocell to act as your retaining wall, your end treatment. Then we get into precast panel walls, other RICO walls or lock and load walls. And as this is a national presentation, some products are not available in all areas. But again, contact your Armtec representative for the application that's available for near you. And this is another picture of the installation of the lock and load walls. Last picture I have of some end treatments. This was a project that was done in Newfoundland this year to replace a wooden bridge. It's in English Harbour in Trinity Bay. It's aluminum box culvert with a full aluminum invert. Therefore, was no concrete footings required. Had aluminum head walls and wing walls. It's all marine grade aluminum. The head walls come custom fit to the shape of your structure. Installation went really easy. No wait times for concrete to cure. As you complete the structure, you can start your backfilling right away. And this one here was, it's the ocean, the tidal waters. come into the culvert at high tides and back out through then at low tides. So it's always basically in contact with the salt water. And to sum it up, most all of our products do have case studies done for different applications. They're available online or from any of your Armtec representatives. And at the end of our presentation, there is a form. You can fill out a survey. And if you want to be contacted by any of our Armtec representatives, please tick off yes. And we're only glad to talk to you and help out your needs. Back to you, Janine.
Great. Thank you, Roger, and thank you, Patrick, for your presentations, and thank you, everyone, for joining today's webinar. Our question and answer period is coming, so please continue to submit your questions. First, I'll quickly review a few housekeeping items, so stay tuned for the question and answer session. As you saw in the presentation, there are a lot of technical considerations for culvert design, and when the need arises, Armtec can support you through the selection and structural design process. Feel free to contact us at any time. Our presenter's contact information is shown on the screen, and they can help answer your questions or connect you with a local rep near your project location. Okay, today's presentation was the second of our fall webinar series. We have our fall webinar series, our final fall webinar coming up soon, which will take place on December 11th and will be the second of this two-part series on culvert design titled Keep It Flowing, Culvert Design 201, and will go into greater detail on the structural design and durability of culverts. You can find all the details and register on our website. Also, as a reminder, please send in your name and email to webinars@armtec.com for your CPD certificate. Please stay connected with us. You can follow us on social media. You can also view past webinars on YouTube, and you can get all the latest on Armtec by following us on our website. We really do value your feedback, and at the end of the webinar, there will be a quick exit survey, and we want to know what you think of the event. Question 6 will ask you if you're interested in receiving more invitations for Armtec webinar events. Due to strict Canadian anti-legislation laws, we are required to have your consent to receive future invitations for webinar events. So please, to ensure that you're on our mailing list, please choose yes, so we can continue to have you as our guest. Thank you for joining today, and now we'll move into questions and answers, which will be moderated by James.
Thanks, Janine. Question came through during Patrick's presentation. How are construction scratches repaired on aluminum and polymer coated pipes?
Well, for aluminum and galvanized coated pipes, you would use a zinc-rich paint or primer. There isn't a aluminum type paint out there, so we do use that paint even in our shop to touch up aluminized steel culverts. And for polymer laminated culverts, the best solution is to use a butyl tape. It's Denso 35, made by, the manufacturer. I guess Denso might be the manufacturer, but it's a mastic that will stick to the pipe. All you have to do is clean the area, and it does a good job holding up over time. We do supply that on major jobs. We'll send a roll or two along with it sometimes.
Great, thanks, Patrick. Another one, just clarifying that, what is the risk of accelerated corrosion for minor damage during installation? Is it a total failure, or?
Good question. Not a total failure. A polymer laminated culvert actually is galvanized culvert with the polymer lamination on top of it. Polymer coated structural plate will have a zinc primer beneath the polymer coat, so you're not looking at completely bare steel, but still definitely a good idea to repair scratches.
Do you have studies or papers that show years of durability on the various solutions provided?
Yeah. Do I have them at hand? No, but definitely there's been lots of research in galvanized steel. You could go to galvanizeit.org. Aluminized steel has been in use for a few decades now. If you have specific questions, we could get you in touch, people that can answer them. And same with polymer laminated steel. It's a little bit more recent of a development. I don't have any research papers on hand that I know of. But again,
I guess CSDI and Plastic Pipe Institute have a lot of research data as well.
Plastic Pipe Institute would have a lot of information on polyethylene culverts, for sure. And you might find some research on aluminized and polymer laminated steel at the CSPI website.
There's just a question on clarifying SRPE versus HDPE. Maybe if one of you guys want to just re-clarify the difference there.
Okay. Well, an SRPE is a steel reinforced polyethylene type pipe. Essentially, you're looking at a pipe with a smooth inner wall, similar to traditional polyethylene pipes, but the strength comes from steel reinforcing, which is usually wound and on the outer portion of the pipe. The key is that steel is completely encapsulated in polyethylene. So you get the strength and stiffness of a corrugated steel pipe, but with the durability of polyethylene pipe. So that's why we sort of categorize them in the same area, because of the durability.
And if anyone's looking for more information on that, if you go to the Armtec YouTube channel, there's a full webinar. There's been a few full webinars on Duramax SRPE pipe, so you can have a look at that there as well. Here's one. I've read that installing the culvert approximately 30 millimeters below the ditch invert offers hydraulic advantages to low flow conditions. Can you comment on that?
It really depends on whether it's inlet or outlet control culvert. It's kind of a difficult question to answer. But generally, what will happen is you install a culvert below the natural stream grade, and there's sediment in the stream, then it will accumulate in the bottom of the culvert up to that level. It's just sediment will follow the path of least resistance.
At the design stage, do agencies have a procedure to estimate culvert deflection? Is there any automated method to measure and control deflection during the life of the culvert?
That would be a geotechnical problem. Along the length of the culverts, all the culverts that we spoke about today are flexible, and they will conform to the ground, the alignment on the ground. So that'll be a geotechnical problem to determine how much settlement and at what point along the length of the culvert that might occur.
A question for the multi-pipe installation versus single pipe. What are the considerations that influence this?
The pipes were as an overflow, just because the location there was an arch pipe used there, and then the other ones were 1200 millimeters that were used as an overflow, just in case a flash flood again would happen, which just alleviate the pressure from the arch pipe.
Semi-corrugated couplers with O-ring gaskets, is the coating affected by the reformed end of the corrugation?
That's in the record ends would be painted with the zinc rich paint, as Patrick alluded to. That any damage done to the coating would be touched up with the zinc rich coating.
And if it was polymer laminated pipe, that would also be painted with a polymer type paint, or a bituminous paint.
There's a really interesting question. Everything fails at some point. Designers are often faced with selection of an appropriate return period to protect infrastructure or property. Please comment on the incorporation of a predictable failure mode into design and construction for different types of culverts.
In types of failure mode, the most common types of failure will be either hydraulic failure, where the culvert is undersized for current conditions, right? Because we have lots of culverts out there that are currently undersized but weren't at the time of installation. And then there's the durability aspect. So a culvert, over time, if it goes beyond its service life, you get corrosion and you can get loss of steel or pipe material, and then eventual failure. The fortunate thing is that flexible culverts, they're quite resilient, and they do not often, if you can see the culvert, they do not often result in catastrophic failure. You'll often see warning signs like sagging or cracking pavement before you actually reach failure. You'll usually get deflection before failure. So you get, as with any type of flexible system, you get warning signs. So that's good.
I want to thank everybody for joining, and feel free to send more questions if you'd like to webinars@armtec.com, and we'll make sure that we get back to you. Thanks everybody for joining, and we look forward to you joining our next webinar.